Bismillahirrahmanirrahim. We stopped here last time, so as we said that the motivation for the go back end was to enhance the efficiency of utilizing the channel, because the stop and wait tends to wait for a long time before the acknowledgement comes, and the window size is 1, which means that we can send only one packet at a time. And then every time we have to wait for the acknowledgement, which wastes a lot of bandwidth of the channel. So to tackle this, we discussed the go back in which case we use like a window. During this window, we are allowed to send multiple frames before we receive the acknowledgement. So we can send 2 to the power m frames before we have to wait for the acknowledgement. If we send all the packets or all the frames in the window without receiving the acknowledgement, then we time out, in which case we have to go back from the beginning of the window. So for the go back end, the size of the send window must be less than 2 to the power m, and we discussed this. And the size of the receiver window is always 1. And we confirm this because it's very important. So there is no change when it comes to the receiver design. The receiver design is still the same compared to stop and wait. So just the fact that we changed the sender to have a sender window of 2 to the power m, it doesn't mean that we need the same window on the receiver side. That's why, because simply the receiver always receives frames in sequence. So I'm always expecting to receive a particular frame in order. Okay, so I will never accept any frame after this or before this. I'm always expecting to receive one frame only. That's why the window size for the receiver is 1. And as we can notice, the summation of the sender window and the receiver window is the sequence number. Okay, so that's a small observation that we should pay attention to. That's why we said that the size of the window has to always be 2 to the power m minus 1, and minus 1 is to actually account for the window size of the receiver. Why? Because as we have explained in the previous slide, if the acknowledgement is repeatedly lost, okay, I need to be able to make sure that when I send the first frame in the window, that the receiver will correctly discard this frame, because it's expecting another frame which is at the end after the window size of the sender window. So the summation of the window size at the sender and at the receiver in total will be the size of the sequence number, which is 2 to the power m. Okay. So in terms of code, as we said, the size of the window is 2 to the power m minus 1, and to maintain or to control the window, we need 3 pointers. We need pointer at the beginning of the window. We need pointer to refer to the current position in the window, and then we need another variable to account for the size of the window. The size is important because we need to make sure that we stop at the end of the window. Okay, so as usual, we loop forever, and then we start processing the events. And in terms of high-level events, we said that there are 3 types of events that the sender needs to wait for or needs to process. The first, the request coming from the higher layer, the request to send a frame, the arrival of an acknowledgement from the receiver, and the third one is a timeout. So if the event is request to send, okay, then I need to make sure that when I try to send that, I did not hit the end of the window, because if I do that, then I have to stop. Similar to stop and wait, but here I'm allowed to send more frames before I have to stop. So the first check I have to do is that whether I'm within the window or I reach the end of the window. So if I reach the end of the window, then I go to sleep. Sleep معناها إيه? Sleep means that, okay, go back to waiting for another event. Okay, so it's like you go out and you go to the while loop to wait for another event. Okay. Otherwise, you will get data. You will of course store data for retransmission. Okay. So store data. This is for ARQ. So we need to store the frame in a buffer in case you want to retransmit. And then you send the frame, and then you advance the sequence number, which means that advancing the sequence number here does not mean sliding the window. Huh? Pay attention to that. Advancing the sequence number meaning that you go one step further within the window. Sliding window comes from what? From here, from this SF. SF points to the start of the window. So if I increment SF, this means that I'm sliding the window. But incrementing SN, this means that I'm normally going through the frames one by one, but I'm still within the window. Okay. The other thing I need to do is that if the timer is not started, then start it. Okay. And one thing to pay attention to here is that even though I'm allowed to send multiple frames within the window, but I'm using only one timer. That's why I'm saying a start timer. That's it. I'm not starting a specific timer. It's just one timer for the whole transmission. Why is that? Because I'm always sending frames in order. So in case of any timeout, I know where I have to go back to. I go back to the beginning of the window, always. Okay? So it's only one timer. Because if it times out, as we will see in a minute, then I know that I have to go to the beginning of the window and send the frames again from frame 0, from the first frame in the window. Okay? So that's why I only need one timer for the entire transmission. And that's very key. You have to pay attention to that. Okay, so the second event, the arrival of an acknowledgement. So what we need to do for the arrival of the acknowledgement is that, again, when I receive any packet, the packet itself might be corrupted, in which case I will just ignore it. Otherwise, so if the acknowledgement number is within the window, is there a possibility that I receive an acknowledgement and it would be outside the window? Could be. So that's why I have to check that the acknowledgement number is within not only the window itself as a whole, but within the beginning of the window and SN. Right? Because SN is the last frame that I sent. Right? So it doesn't make any sense that I receive an acknowledgement of SN plus 2 or SN plus 3. These are frames that I didn't send yet. Okay? So I have to make sure that so we have a window that looks like this. I sent these 2 frames. Okay? So I can receive, if this is like frame 0 and this is frame 1, let's say. Okay? So I can receive an acknowledgement of 1. What is the meaning of receiving an acknowledgement with an index 1? This means that the receiver is telling me that I have received successfully frame 0, please send me frame 1. That's what this means, right? So I can receive an acknowledgement of index 0, I can receive an acknowledgement of index 1, I can receive an acknowledgement of index 2, because this means that, because I already sent 1, so this means that the frame 1 which I sent has been received successfully, and the receiver is telling me to send him frame 2. So frame 0 and frame 1 are all okay. And I can receive an acknowledgement of 0 or 1 or 2. Okay? So I have to always make sure that, that's why we have here greater than, and here we have less than or equal. Okay? Because always SN is here, which is the one that I'm trying to send now. I can receive an acknowledgement which is equal to SN. Okay? So if I receive an acknowledgement which is within SF and SN, this means that this is a valid acknowledgement. I need to process that. And the way I process it, what do I need to do when I receive an acknowledgement? Slide the window, bravo Ali. So I need to slide the window. Okay? Here we use the concept of accumulative acknowledgement, which means that if I'm sending, if I receive an acknowledgement, let's say that this is 2 and I receive an acknowledgement of 3. Okay, so SN is here and I receive an acknowledgement of 3. Okay. This means, remember, SF is at location 0, at frame 0. But I receive an acknowledgement of 3. Is this valid? Yes, it's valid. This means that the receiver is telling me that it received 0, 1, and 2 successfully, and it's expecting to receive 3. So this is what we call accumulative acknowledgement, which means that it acknowledges not only the reception of frame 2, but by default, because I'm sending everything in sequence. So this implicitly means if the receiver is telling me it has received frame 2 successfully, so it must have received frame 1, and it must have received frame 0. Okay? So receiving one acknowledgement can acknowledge multiple frames at a time. That's what we call a accumulative acknowledgement. And this is valid because we always receive things in order. Okay? So in that case, I need to slide the window. And slide the window here, that's why the accumulative acknowledgement accounts for the fact that we have a loop here. Not just slide the window one position. I have to slide the window all the way up to the acknowledgement number. So because this means that the receiver has received everything, so it's okay for me to slide the window all the way until I hit the acknowledgement number. So while SF is not the acknowledgement number or equal, keep sliding the window. So I can slide the window here potentially more than one time. Okay? And also because I received an acknowledgement, everything is fine, then I can stop the timer. There's no point of keeping the timer because the timer is an indicator that I did not receive the acknowledgement. Then I need to wait for a specific time. Since I have received the acknowledgement, then I should stop the timer. When does the timer start again? When I try to send again. Okay? If I did not receive an acknowledgement for quite some time, then the timer will expire. When the timer expires, then what I need to do is that I have to go from the beginning of the window. That's why I have to go from SF. SF points to the beginning of the window. Okay? And start the timer, and then I put the temp equal to SF. And here there is a slight problem in the in the book, by the way. I will point this out because this is temp, and this is temp, not SF. and I'll show you why. So this means that I have to go back to the beginning of the window and send the frame at the beginning of the window again, and then send this again, and then send this again, and keep sending until I hit the SN. So while temp is less than SN, keep sending the frames again. Okay. So why this is temp and not SF? Because remember when the timeout happens, incrementing SF meaning what? Means what? You're sliding the window, right? Should I really slide the window? No, you should not slide the window because you did not receive any acknowledgement, right? So here, this is a typo. So that you should send the frame at temp and increment temp. Temp is like a temporary variable. ماشي? It's like you are creating another copy of SF, and then you start sending frames starting from SF all the way to SN. But you should not increment SF, because incrementing SF meaning that you are sliding the window, and you should not do that. Okay? Any questions? So that's it for the. We will notice that the receiver is actually it's exactly the same. The receiver is exactly the same like the stop and wait. There's only one slight change here, which we'll mention quickly. But this is due to the implementation. But conceptually, it's exactly the same. As we can see, there's only one event here, which is the arrival of the data. When the receiver receives the data, then it tries to check first if it's corrupted. If it's corrupted, then it ignores it. Okay. And then because as we said, the receiver has a window size of 1, which means that it's always expecting one frame and one frame only. Okay. So in that case, if the sequence number of the incoming frame is the one that I'm expecting, only then I can send the acknowledgement. Because otherwise, I just ignore it. Okay? So if the sequence number of the incoming frame is the one that I'm expecting, then only then I can deliver the data to the upper layer, and then I increment Rn to point to the next one. And then, as we can see, incrementing the Rn comes before sending the acknowledgement. Why? Because I always send the acknowledgement number as the one that I'm expecting next, which means that I received everything before successfully. And this is by default an accumulative acknowledgement. And we will see on the timing diagram the concept of accumulative acknowledgement. Okay? So this explains the timing diagram that shows the next slide. So instead of just going through the words, we just explain it on the timing diagram. So this explains the concept of accumulative acknowledgement. So what that means is that first we have here a window size of 8. Sorry, window size of 7, and the sequence numbers are starting from 0 to 7, which means 8 different sequence numbers. So the rule is fulfilled. So the size of the window is 2 to the power m minus 1, right? And here is 3. So at the beginning we said that SF and SN they both point to the first frame. We then increment SN as long as we try to send more frames. And then SF will increment it only if we want to slide the window, and that happens if we receive an acknowledgement. Also, as we said, that we have only one timer for the entire window. And why is that? Because, again, we expect to always send the frames in sequence. So in case of any timeout, like here, we have to go back to the beginning of the window. So we only need one timeout. Of course, the calculation of the timeout has to take into consideration the transmission time of all the frames inside the entire window. Luckily, we don't have to go through the calculations of the timeout here as part of this course, but I can tell you it's a bit complicated. It has to take into account the number of frames in the window, the transmission time, the propagation delay, and so many things, and some safety factors and things like that. So, so if I send a frame number 0, and then it happens that before sending frame number 1, the receiver has received frame 0 successfully, and it has sent the acknowledgement. In that case, it's fine. I can just slide the window, and that's what happened in this case. So SF has been incremented because I have received the acknowledgement. So until in this period, it's almost stop and wait, right? So I sent a frame and I received the acknowledgement, so I slid the window and that's it. So I tried to send frame 1, the acknowledgement, which has an index of 2, which tells me that, again, I received frame 1 successfully, send me frame 2. This acknowledgement was lost. That's fine, because I'm using the window technique, so I will keep sending frame 2, right? I sent frame 2, and the acknowledgement, it was not lost, but it was delayed a little bit. Then I don't have to wait, so I can send frame 3, right? So I sent frame 1, frame 2, and frame 3, even though I did not receive the acknowledgement for 1 yet. For the receiver itself, it has received frame 1, but the acknowledgement was lost. So when it receives frame 2, it will increment Rn and it will send acknowledgement 3. Okay? So acknowledgement 3 will override acknowledgement 2, which was lost. That's what we call accumulative acknowledgement. So just the fact that we lost acknowledgement 2 here, it did not affect anything. And that's one good thing about the window technique. Even if we lose some acknowledgements, that's fine. Okay? So acknowledgement 3 here will cause the window to slide 2 positions, right? Because acknowledgement 3 indicates that I received frame 1 successfully. I received frame 2 successfully. I'm expecting frame 3, right? So I will slide the window until I hit the acknowledgement number, which in that case, 3. Right? And then I will keep doing the rest of it. So this explains the concept of accumulative acknowledgement. So even if we lose some of the acknowledgements, then we do not lose anything, because the concept of accumulative acknowledgements will take care of that. So that's it. So the second scenario here talks about the fact that for ARQ, for automatic repeat requests, if we lose a frame, not acknowledgement, okay? If we lose one frame, then if we lose one frame in the window, because because we send everything in sequence, the receiver will never accept anything after that. Okay? So the previous scenario shows one good advantage about go back in. This is a disadvantage. Even compared to stop and wait, This is a disadvantage. Why? Because the window technique, only one frame within the window has been lost. Okay? Will cause the fact that I will keep transmitting all the frames after that blindly, because I don't know. I will have to keep transmitting things all the way until the timeout expires. And when the timeout expires, then I have to go back to the beginning of the window and retransmit all the frames from the beginning. This is a disadvantage in the go back end. So even though we have gained the fact that the channel utilization has been enhanced drastically, because we keep sending frames without waiting for acknowledgement, but if only one frame is lost, remember that the receiver here is expecting, here for example, the receiver is expecting frame 1. So it's Rn here is pointing to frame 1. This frame has been lost. The sender will not know that this frame has been lost until the timeout expires, right? So it will keep sending frame 2, frame 3. So I keep sending things, I don't know, right? So, and the receiver, when it receives frame 2, Rn here is pointing to frame 1. So it will ignore it, right? Because of the order transmission. Sending frame 3, ignored. I cannot accept anything out of sequence. Okay? Then the timeout expires. So I had to send frame 2, frame 3, wasted. Okay? Because I don't know. And the timeout here expires. When the timeout expires, what I will do is that I will blindly have to go back to the beginning of the window. This is the only way, because I'm always sending things in sequence. Why am I repeating this? Because, of course, to try to solve this, we have to look for another way to send things out of sequence. And that's what the selective repeat tries to do. But we will see that in order for us to do that, we have to increase the complexity in an order of magnitude. So when the timeout happens, I have to go back and send frame 1 again. So send frame 1 again, and it was received this time. When it was received, then I send acknowledgement 2, and I keep rolling after that. So when the acknowledgement comes, I'll slide the window and so on, and I keep doing this. Normal procedure after that.
When we calculate the time for the time, should be for the whole packet.
That's a very good question. This tells you that you should have a trade-off in calculation. That's why I said that the calculation of the timeout is a bit complicated. Why? Because if I make the calculation of the timeout to span the entire window frames, then if the first frame has been lost, then I will assume that the window size is 14 or 16, okay? I sent the first frame and it was lost. Imagine what will happen. If the timeout is long enough to span the entire window, what will happen? I will send 15 frames and all of them will be wasted. صح? Okay, so if I make it very short, then even if the acknowledgement was delayed a little bit, it will expire prematurely. Okay? So it looks like there is some optimization techniques that have to be taken into consideration when it comes to calculating the timeouts. It's not easy. So you have to have a trade-off. It's not related to the entire window size, and it's not very short. It has to be somewhere in between. Okay. Does that answer your question? Okay. So Of course, we talked about this. Stop and wait is nothing but go back in with a special case of the window size is equal to 1. So that's a fact. So the scenario that we just discussed was the motivation for trying to resolve this through what we call selective repeat. So we need somehow to allow the receiver, if frame 1 is lost, accept frame 2 and frame 3. And I promise you I will send you frame 1 later. Okay? That's what we will try to do now. So, which means that the receiver will not have one pointer that points to one location and it always expects this to receive this frame. It can accept the current location or maybe few locations after, which means that the receiver will have a window, not that just one, will have a window of frames that it can expect. So it may not receive the first one in the window. If it receives frame 2 or frame 3 before frame 1, it is allowed to accept them. Okay? So in that case, it becomes very complicated because if the receiver has a window, then does the size of this window equal to the sender window? When do I have to slide the window of the receiver? So when I receive a frame, again, what is the relationship between the window size of the sender and the window size of the receiver and the sequence number? So we have to think about all these things. So the selective repeat, it uses the same concept from the sender point of view, that we have a window, but one very important thing to pay attention to here is that the size of the window here is 2 to the power ma minus 1 frame in the exponent, not minus. So which means that the window size here is half the sequence number. Why? Because the window size of the sender will be equal to the window size of the receiver. And as we said, the window size of the sender and the receiver in total will have to be the sequence number. In the go back n, the window size of the receiver was 1. That's why we said that the window size of the sender has to be 2 to the power m minus 1. But here, we have to have another window size at the receiver, right? Which is equal in terms of size, and that's why each one will have to be half. ماشي كده؟ And we'll see when we go through the timing diagram, this will become clear why we need the window size here to be half. The receiver will have a window in that case, which is equal to the window size of the sender, which means that the receiver can expect any frame within that window. Not necessarily the first one, as the case of the go back n. In the go back n, the receiver has a window size of 1, which indicates that I'm always expecting one frame only, because everything is in order. Here, it's slightly different. The receiver needs Rn, which is the one that it should expect, but it can exceptionally accept any frames after that, given that it's within the window. And again, the window size is half the sequence number. So what does this mean conceptually? This means that the sender tries to send frame 3 and it was lost. Then it tries to send frame 4 and it arrived. So the receiver will accept it. Unlike go back N. Go back N, this would not happen. But for the selective repeat, I will do it. Why? Because I don't want to waste bandwidth in retransmitting these frames again. That's why it's called selective repeat. Selective, I'm selecting the frames that I should repeat. Okay? Then I send frame 5, it was lost. Send frame 6, it was lost. Send frame 7, okay, it arrived. That's what this means. So the receiver is slightly more complicated, but then the sender as well has to be slightly more complicated, as we will see. So the rule here is that the window size for the receiver and for the sender has to be half the sequence number. So in terms of high level, again, it's the exact same 3 events. The sender will expect the request from the network layer, or the arrival of the acknowledgement, or the timeout. One thing to pay attention to here is that the timeout for the sender has to be associated with the frame number. So even though the sender will have a window, and the window size is half the sequence number, as we said, unlike go back N, one very important difference here is that we have to maintain multiple timeouts, multiple timers for each frame in the window. Why? We'll talk about that. Okay? But this is very important. Why? Because again, يعني conceptually حتى احنا نفهمها. For each frame, I have to set a timer, because I can receive an acknowledgement for any frame. يعني مثلا I'm sending frame 1, setting a timer for frame 1, sending frame 2, setting a timer for frame 2, sending frame 3, setting a timer for frame 3. The receiver may actually lose 1 or lose 3, so it will send acknowledgement only for 2. But 1, when it expires, the timer for 1, when it expires, then I send only 1, or I send only 3, and so on. That's why I need to unlike go back N, because go back N, simply if the timer expires, then I know what to do. I will have to go back from the beginning of the window all the time, regardless. صح? And here, I have to be selective. So selective has actually initiated some complexity that I have to maintain multiple timers. Okay? Okay, so let's see why the window size has to be half. Again, we know conceptually that the window size of the sender and the window size of the receiver have to be at maximum the sequence number. But this shows the timing diagram why the sequence number or the window size of the sender has to be 1/2 in that case. So the sender, when it sends, again, the idea is that for every frame we send, the acknowledgement is totally lost, which indicates that the back channel is very bad. The forward channel is good, but the back channel is very bad. Okay, so we send frame 0, acknowledgement was lost. Remember that when I send frame 0, Rn is pointing to 0, so Rn will advance, like here. Okay, so when I receive a frame correctly, I slide the receiver window. right? Because I received the frame correctly. When I slide Rn, similar to go back in, I slide Rn, I increment Rn, which means that I'm sliding the receiver window. This here indicates the fact that I'm pointing at frame 0. I'm expecting frame 0, but I can also accept frame 1 if it arrives before 0. Right? That's what this window means. If I receive frame 0 successfully, then I will slide. So slide. Frame 1 came. Acknowledgement was sent, lost. So again slide. So now the position of the receiver window is at 2 or 3. 2 or 3. Here I did not slide the window because I never received any acknowledgement. That's why we said that the total of these two windows should be at maximum the sequence number, which is in that case 4. So why? Because simply losing the acknowledgement means that the two windows, one window will keep sliding and the other window will never slide. So the total of them should never exceed the sequence number, because if it does, then this frame 0 will be accepted erroneously, which happens in that case. But here, frame 0 is not 2 or 3, so I will not accept it, right? So when I go back here and I send frame 0 again, because the timeout for frame 0 has expired. So I try to send frame 0. The receiver is expecting 2 or 3, right? So in that case, it will discard it correctly. Here, if we increase it just by 1, if we increase the window size by only 1, so in that case, when the receiver window slides, 0 here will become one of the frames that the receiver might accept, right? So when I try to send frame 0 again, this will erroneously be accepted. But remember that frame 0 here is this one, whereas I have put it by mistake here. And remember that those two frames are different. They have the same index, but the content is different. معايا في الموضوع ده؟ These frames are different. The content of these frames are different. Just the fact that I'm giving the index number to the frames, it doesn't mean that they are the same. يعني we have frame 0 here and we have frame 0 here. We have frame 0 here and we have frame 0 here. But those are two different frames. Because of the fact that the receiver has slit the window, it accepted this frame 0 and it put it in the future frame 0. So this will corrupt the whole thing. Right? This will corrupt the whole thing. So this will cause the synchronization between the sender and the receiver to be totally missed. So this will cause some missynchronization between the sender and the receiver. So that's because of the fact that when one window slides and the other window does not slide, because of the fact that the acknowledgement was never received by the sender, they both should never slide more than the span of the sequence number. So the total size of the window size and the receiver window should never exceed the sequence number, which in that case it's 4. So if it's 4, this means that sender window should have 2 and the receiver window should have 2. ماشي؟ Any questions? So the selective repeat ARQ, the sender, the size of the sender and the receiver window must be at most 1/2 of the sequence number 2 to the power. So the sender window size is 2 to the power m minus 1 in the exponent, and then the start and Sn, the start and the current pointer should point to frame 0, and then we do the exact same thing. One slight difference here that you notice is this. If you remember in the go back M, we would start timer, that's it. Now we start timer for each frame. So each frame should have a separate timer in that case. And that's one important difference. And this adds some complexity, of course. But again, we are complicating things because we don't want to send all the frames in the window in case we lose one frame. It doesn't make any sense. Okay? So we are trying to increase the efficiency of the channel, but if there is any one error, we have to go back and send the whole thing from scratch. So we're trying to avoid this by using the selective repeat. But for being able to do that, we have to start one timer for each frame. And that's one cost that I have to pay. Okay? So when we receive the acknowledgement from the receiver, here we have to pay attention to what we call NAK. This is what we call a negative acknowledgement. The use of negative acknowledgement here is then just to enhance the efficiency a little bit. Why? Because if the receiver receives the frame and the frame is corrupted, okay, I can ignore it. I can just discard the frame, right? I can discard the frame, and then if I receive the frame after, I will accept it, and things will work. Yani if there is no knack in this picture, things will still work. But what I'm trying to do here is that if I know a fact that this frame is corrupted, I might as well inform the sender so that it sends this frame now, rather than just waiting for some time and receive things out of order for quite some time, and then I have to go back and send this frame again. So if I know a fact now, I might as well inform the sender so we can resolve it as soon as possible. But again, the use of NAC here is you can say it's optional. It's just for increasing the efficiency, that since I can at any point in time inform the sender to retransmit a specific frame, I know that this frame is corrupted, so I might as well tell the sender now. Okay. So if the acknowledgement is corrupted, then I have nothing to do. If the acknowledgement is corrupted, I just ignore it. If this acknowledgement is a negative acknowledgement, then the negative acknowledgement will have a number, just like the acknowledgement. The negative acknowledgement indicates that this frame has been corrupted. Okay, so if the frame type is negative acknowledgement, then I have to first of course the negative acknowledgement has to be within the window, of course. So it has to be within the window that I'm trying to use for transmission. So if that's the case, then I will have to retransmit only this frame, only one frame. The negative acknowledgement is not accumulative in that case. Remember that. Only acknowledgement is accumulative acknowledgement. Negative acknowledgement points to the fact that one frame specifically has not been received successfully, or has been received but corrupted. Because if it's totally lost, I cannot send a NAC for something that did not actually reach the receiver. معايا? So NAC means what? Means that I received something, but it was corrupted, unfortunately. So in that case, I resend that particular frame only. That's why we don't have any loop. And sending معناها ايه? Start the timer. Start the timer for this particular index, for this particular frame. And start the timer here. If the timer was already started, then it will restart. Okay? Stop and start, yeah. Type. If the frame type was an acknowledgement, then remember acknowledgement is accumulative acknowledgement. That's why here we have a loop. An acknowledgement means that we slide the window. So in that case, we have a loop starting from SF all the way until I hit the acknowledgement number. I will keep purging, stop the timer. Stop the timer do one extra step that it did not exist for the go back N. For the go back N, if you go, you will find this outside of the loop. Why? Because it's only one timer for the entire window, so I will stop it only once. But here I have to stop every timer for all the acknowledgement that I received successfully. ماشي? Because again, we have one timer for each frame. So the sender in that case, the only difference, there are two main differences. One is the use of negative acknowledgement, and the other one is the use of individual timer for each frame. So those are the two main differences for the sender. Receiver on the other side, this is the timeout. For the timeout, of course, remember that the timeout refers to the timer of a specific frame, right? So in that case, all I need to do is just to send that particular frame, unlike go back in. So I only need to send one frame, unlike go back n, which I have to go back to the beginning of the window and resend all the frames again. And this will increase the efficiency now. So I don't have to waste time by resending all the frames again. I only send one frame, which is the one that expires only. Okay. So in that case, the timeout calculation is based on the transmission of one frame only. Okay.
T is the frame?
Yes, T is the frame number. T is the frame number. يعني it indicates any variable. This is given. يعني when the event happens, it gives you one of the parameter, which is the timer number. The timer number is equal to the index of the frame that was not acknowledged. So in that case, I only need to send that frame only. The receiver has been complicated a little bit. It's still one event. I'm processing one event, but now I have to keep more variables. I have to keep maintaining more variables in that case, and we'll see why. So the first thing is that we have Rn. Rn is a normal variable. We know that. We're familiar with that. The other thing that I have to pay attention to is the negative acknowledgement sent. the fact that I have negative acknowledgement sent as a flag, this means that I don't want to send several negative acknowledgements for frames until I don't want to once I send negative acknowledgement, I have to receive that frame before sending another negative acknowledgement. Because once I send negative acknowledgement, this means that I need you to resend that particular frame. Right? When you send me this frame, I can send you another negative acknowledgement, right? But if I send you negative acknowledgement for a particular frame, and you did not send me that frame, then another frame was corrupted. So I send you a negative acknowledgement for another frame. This will wipe out the first. Right? So I don't want to send multiple negative acknowledgements until I receive the frame, the first frame that was corrupted. So this conceptually, why I need a flag. Why I need a flag is that I don't want to repeatedly send you negative acknowledgement before you start processing them one at a time. The other main difference here is that I need to mark each slot in the window of the receiver. So the receiver again, the receiver window has a window size of half the sequence number, right? And as we said, I may actually receive this frame before this frame. So I can receive those two frames before the others. So in that case, I need to have a marker that tells me whether this frame has been sent, or this frame has been sent, or this frame has not been sent. Right? So at the beginning, I need to go through all the frames and mark them as false, which means that they have not been received. Once I receive a frame, I will mark it as received. Why do I need to do that? Because I need to, when I slide the window of the receiver, when do I slide the window of the receiver? I actually receive this frame before this frame, right? And then I receive this frame before this frame, right? Later on, this frame at the sender has been timed out. So the sender will retransmit this frame. So now I receive this one. Should I slide? No. It doesn't make sense. If I slide, I did not receive this frame yet. If I slide one position, then this frame will never be received. So I cannot slide. Later on, the timeout of this frame has expired. The sender will send this frame. This frame has been received. Should I slide? Yes. How many positions? 4. So I slide all the way. I slide this one, this one, this one, this one, and then I'll stop here. Right? So that's why I need a flag that tells me whether this frame has been received or not. Why? Because when I slide, I need to check, was this actually received? If the answer is yes, then slide. If the answer is yes, then slide. And I keep sliding until I hit a frame that was not received. Okay, Kira? So that's why this marked flag is important. So if the event is the arrival of a new data, then I receive the frame. Then I ask myself, is this frame corrupted? And this is what we said, that in the go back in, we didn't have to do anything because we always send things in order, and I mean, no matter what I do, the sender will have to go back from the beginning of the window anyway. But here, because it's selective repeat, I need to inform the sender whenever I know anything. Because if the sender can send things out of order, then it might as well send me this frame now. Okay, but as I said, this is optional. If we don't send the negative acknowledgements, things will still work, but a little bit less efficient. So if the frame is corrupted, if the data frame is corrupted, then this is what I need to do. I need to send a negative acknowledgement with the index of that frame only. This frame has been corrupted, then I only need this frame only. Okay? And then I set the negative acknowledgement flag to false, as we said, because I don't want to send repeatedly negative acknowledgement before you process it. It doesn't make any sense for me to keep sending negative acknowledgement if you don't process it. Okay? So if I receive a frame and the frame is not corrupted, the frame is good, then I have to ask myself, if the sequence number is not Rn, this means what? This means that unfortunately I'm receiving a frame which is not the one that I should expect. So in that case, I should accept it. I know that I should accept it. But if negative acknowledgement sent was false, which means that I did not send negative acknowledgement before, then I will send negative acknowledgement to indicate that I did not receive the current frame yet at Rn. I will accept it. I will accept what you gave me, but I did not receive. Pay attention to the fact that I did not receive the current frame yet. Okay? So here, negative acknowledgement is true. So 1 second. Yeah, and if the sequence number is within the window, then I will accept it. Yeah, if the sequence number is not Rn, then I should send a negative acknowledgement, and then I will see. If this negative acknowledgement is within the window, I should accept it. Accept it as if the sequence number is within the window and I did not receive it before, which means that marked as sent is false, I did not receive it before, then I will accept it. Store the frame and then mark the frame as received, and then I will see. Should I slide the receiver window or not? As we said, slide the receiver window happens only if there are some marked frames from the beginning of the window. As we said before, if the window is like this, I receive this frame. Rn is here. This is Rn. Right? Should I slide? This one is marked as false. Then no slide. Then later on, I receive this frame. Again, I ask myself, should I slide the window? Let's see, this frame is marked false. Then I should not slide. Then I receive this frame. Should I slide the window? Yes. Then this loop goes through these frames one at a time. Is this one marked as yes? Okay, yes. Then I increase Rn. Is this one marked as yes? true, then I increase a rn. Is this one marked as true? لا, it's false. So I stop. So I always stop rn at the frame that marked as not received, to indicate that I'm expecting this frame to be received now. I can accept others within the window, but I should expect this one if you are sending things in sequence. Okay? Right. While I'm sliding the window, this means I received a frame successfully. So, then I should send positive acknowledgement. Okay? But as we said, the acknowledgement is always accumulative. Negative acknowledgement is individual, but the acknowledgement is always accumulative. That's why we have a flag called a acknowledgement needed. I could actually say while marked RN and send acknowledgement. But what does this mean? Yani, I'm actually acknowledging this frame and this frame and this frame repeatedly. I mean, there's no point. Sending one frame accumulative will override all this acknowledgement all at once, right? So in order for me not to repeatedly send acknowledgements many times, I use a flag. Only if I slide the window, this means that I need at least one acknowledgement. So I set the flag to true, which indicates that, okay, if this flag is true, then I need to send one acknowledgement, which is accumulative acknowledgement for all the frames that I received successfully. Okay? So again, negative acknowledgement is always individual. Only separate indicates one frame was corrupted. Accumulative acknowledgement means that our acknowledgement is always accumulative to indicate that I received everything before that number correctly. So in that case, if acknowledgement needed is true, this means that I should send an acknowledgement with RN and then set the negative acknowledgement and acknowledgement needed to false, which means that خلاص, I can later on send this negative acknowledgement once more if I want. Okay? يعني resetting these flags. The logic of processing the event at the receiver side is a little bit complicated, and the only thing we should watch for is the fact that when do we slide the receiver window? Sliding the receiver window is a little bit tricky in that case. And we only need to slide the window if we have the position at Rn here received. When the position at Rn is received, then we slide the window 1, and then we point at the next. If this is received, then we go one more and so on. Okay? And this actually explains that concept. So if Rn points to here, and we have 1 and 2 already received, this means what? This means that the receiver received 1 and 2 before 0. Okay? When the receiver then receives 0, then it asks itself, was 0 received? Yes, then slide the window. Was 1 received? Then slide the window, and so on. So after sliding the window, it will look at the first frame that was not received. That's why we need this marked flag to indicate that whether each frame has been received or not. So this خلينا يعني نفضل 2 slides خلينا نستعمل